We'll take a look at some examples using both the in-center theorem and then the circumcenter theorem as well. But for the first three problems, even though we won't go over all of them, it says N is the in-center of triangle ABC. So just a quick review, what that means is N is on the three angle bisectors of triangle ABC. It says use given information to find the indicated measure. So number one, ND, this length right here, is 2x minus 5. NE is negative 2x plus 7. And then you want to find the length of NF. I'm going to just put a question mark or an unknown here. Since N is the in-center, it's equidistant from the sides of the triangle. That's specifically using the in-center theorem. Therefore, ND is congruent to NE. We could set up 2x minus 5 is equal to negative 2x plus 7. And then solve the equation. Add 2x to each side. 4x minus 5 is equal to 7. Add 5 to each side and then divide by 4. So 4x is equal to 12. And then if I could divide each side by 4, x is equal to 3. Be careful about the direction. Sometimes people think that they're done when they finish solving the equation. We want to find the length of NF. We weren't given an expression for NF, but NF should be congruent to ND, and it should also be congruent to NE. So if we find one of those, then we can find all of them. So I'm going to substitute x back into this expression. 2 times 3 minus 5. 2 times 3 is 6. Minus 5 is equal to 1. Maybe you just want to double check and then substitute that back into the expression for NE as well. Negative 2 times 3 is negative 6 plus 7 is still 1. So that's the length of ND. It's also the length of NE and NF, 1. And if you can do that problem, if you follow that, you should be able to do problems 2 and 3. Maybe kind of try those on your own if you want. On the next few examples, it just says find the indicated measure. It doesn't specifically tell you what point P, G, or N are in each of the triangles. You have to figure out what they are. For example, on number 4, there's point P. What you have to figure out is what point P is. It's definitely a point of concurrency, but you have to figure out what it's made up of. The only things that we've talked about so far are the perpendicular bisectors and the angle bisectors. If you think about it, figure out what point P is in the triangle. If you said it's the circumcenter, then that would be correct because PD is a perpendicular bisector of side AB, PF is a perpendicular bisector, and so on. PD is perpendicular to side AB, and it cuts it into 2 congruent parts. So point P, I'm just going to write this down and make a little note, is the circumcenter, which implies that point P is equidistant from the vertices. So PB is given, the distance of the circumcenter to one of the vertices, that's 13. You want to find the length of PA, these 2 segments, as well as PC, although we don't need to find the length of that, but all of those should be congruent. So if PB is 13, then PA or AP is also 13. And then on number 5, again, try to figure out what point P is in triangle DEF. In this case, point P is the in-center of the triangle. It's the point of concurrency for the 3 angle bisectors. EP is an angle bisector, DP and FP are all angle bisectors. Therefore, point P is equidistant from the sides. That's the in-center theorem. PU is given. That's 8 units in length. We want to find the length of PS. So those should be congruent, PU, PS, and PT. So PS is equal to 8.